Hello, so here we are with some notes for section 4.1 inverses day 2. I don't want to make this video super long, so I am just going to do a couple problems here. I'm going to do number 1, the warm-up, and I'm going to do example 1. Now, example 2, I know you guys are going to copy those down in your notes. That one's a little bit tough, and when I looked at your assessments, it's going to be closer, the ones that you're going to be tested on are going to be closer to something like example 5, where you have a quadratic that's been restricted, or example 1, like we're going to do here with a square root, and then also potentially one with an exponential or a logarithm, but those are ones that you guys have not learned about yet. So let's just stick to warm-up number 1 and example 1 to keep this as quick as possible for you guys. So what we talked about yesterday was using composition functions to determine whether two functions are inverses of each other. So this is when I'm given two separate functions and the question is, are they inverses, yes or no? In order to determine that, we're going to do f of g of x to start, and we want the answer to simplify to an x. So we are going to take g of x and we're going to plug it into the x in the other function. So it's 8 parentheses x plus 8 over 7 and then minus 7. Okay, so let's see. Usually with inverses, things will cancel easily, and we can see here that that's not really going to happen. We're going to get an 8x plus 64, just distributed the 8 to the numerator only, because it's like having an 8 over 1, and then over 7 minus 7. I'm going to rewrite 7 to have a common denominator. And this just does not come out nice. This is 8x, plus 15, all over 7. Obviously, we're not going to get this to equal x. So I can actually stop right there. I can stop right there and say, all right, these cannot be inverses of each other, because when I did f of g of x, I didn't get x. I could go on to try to do g of f of x, but it doesn't matter because they both need to equal x. So therefore, these are not inverses. Yesterday we did an example where we did reduce down to x, and they were inverses of each other. So these ones are not. Okay, so that was number 1 warm-up, and let's do example 1. These are kind of the same every time. Let's find the domain and range of f of x. So f of x is this function, square root of x plus 8. Now, because we've done this first semester, we know that that is a square root function that's been shifted left 8, meaning it starts at -8, and then if you guys remember your quick points, looks something a little bit like this. Okay, now I can see the domain and range very clearly just from looking at the graph, but there's another way to find the domain and range. For all square root functions, okay, the inside has to be positive. So we take the inside and we say, you've got to be positive. Positive means greater than or equal to 0. So subtract over that 8 and we get x, oopsies, is greater than or equal to -8. And as interval notation, that gives me my domain, which is going to be -8 to infinity. So we're greater than -8, which we can clearly see on the graph that the function starts at -8 and goes to the right towards positive infinity. Now the range, all square root functions, the default range is 0 to infinity. That's going to change in 2 scenarios. Either if the function is reflected, so if there is a negative in front, it would flip upside down, so it would be -infinity to 0, or if there was some sort of vertical transformation, so if it went up or down by some amount, then that would also change the range. So those are 2 situations in which the range would change. Now, part D is to find the domain and range of the inverse. I always skip to part D from part A because it's really simple. We're literally just going to swap the domain and range from the original. So my new domain is 0 to infinity, And my new range is -8 to infinity. Perfect, so all I did was just swap the domain and range. Again, the reason is because inverses swap their x values for their y values. So the domain is x values, the range is y values, and the inverse just swaps those. Part B is the function 1 to 1, and we can see, because it passes the VLT, not VLT, I'm sorry, the HLT, the horizontal line test, it is 1 to 1. And then next says to find the inverse. So to find the inverse, we start out by writing y equals the function, so square root of x plus 8. And then we swap the x and the y. So we get x equals the square root of y plus 8. And now we isolate y. So let's square both sides. We get x squared equals y plus 8. And then we're going to go ahead and subtract the 8 over. So now the y is isolated, and that means I can write out that f inverse of x equals x squared minus 8. Gorgeous. Now, the last part says, let's graph that. Here's the thing. If I graph this function, x squared minus 8, let's do a different color than we did the original. So I'll pick green. X squared minus 8 is this. It's x squared shifted down 8. So it's a parabola shifted down 8 like this. Now, wait a second. That is not 1 to 1, and our answer should be 1 to 1. But don't forget, our domain and range is going to be somewhat restricted. Let's see. The domain should only be 0 to infinity. 0 to infinity is over here. And the range should be -8 to infinity, which it is. All right, but since the domain is restricted, that means that literally this half of the graph is not part of the answer. Okay, it's just half of a parabola in my answer. So technically, I also want to say that x, you can just write the domain actually. You could say comma, x is going to be from 0 to infinity. Or you could write x is greater than or equal to 0. So you'll see some math teachers write out the restriction next to the function to say, hey, it is that function, but it's been restricted in some way. All right, so that's my final answer. Part A, Part B, Part C, Part D, Part E. And hopefully you kind of get the gist at this point. Look on your notes for the example 3, but again, it's the same idea. Just don't worry too much about finding the domain and range for this function because we really won't ask that of you. It'll be a little bit more basic like the ones I've been doing with you. So hopefully that answers any questions that you might still have about inverses. Thanks, guys.